Number 12 is the exercise that I'm referring to, that those who were in that workshop will remember that I asked them to work this number 12 and then come back with what they would have worked or what they would have found after working out this exercise. But no problem. Okay, let me start in this way. Is there anyone who remembers amongst us? Yes, no? Because it looks like a number of you don't remember this
Oh,
task.
so we're going back to what we were doing before we went back to limits.
Sorry?
So this is a topic we were working on, I think, 2 weeks ago.
Mm-hmm.
Yes, I found it because I'm trying to keep all the stuff in one book.
Oh. Oh, okay. Did you find it?
Yes, sir.
Okay. Did you manage? Okay, you found the exercise. Did you manage to work it out?
Yes, sir. Because before we left, you also gave us a few hints.
Oh, okay. May I humbly request you to share with us how you approached it?
Okay, sir. I'm just also gonna be reading the question again because I haven't seen it in 2 weeks.
No problem.
So gas is escaping a spherical balloon at the rate of 4 centimeters cubed per minute. How fast is the surface area shrinking when the radius is 24 centimeters? For a sphere with volume equal to 4 over 3 pi r cubed and a surface area of 4 pi r squared, where v is volume, s is surface area, and r is the radius of the balloon. So we established that what they're looking for is how fast the surface area is shrinking. So in other words, the derivative of the surface area formula. And then they also gave us the formula for volume. So we also need to determine, hold on. Oh, they gave us the formula for volume, and they gave us the value for the derivative of volume. So if we find the derivative for volume, we'll have, and we do that by deriving both the left and the right hand side of the formula. We have dv over dt is equal to 4 pi r squared times dr over dt. And then we simplify that formula and we're left with minus 1 over pi equal to r squared times dr over dt. And then to get the dr over dt alone, we divide by r squared on both sides, and then we have dr over dt is equal to minus 1 over pi r squared. And just to explain, because I don't know if I mentioned the minus in before in the previous steps I was explaining for the derivative of volume. We say it's minus because the volume of the balloon, it's losing air. So that 4 centimeters cubed per minute is going to be negative because it's coming out of the balloon. Then I derived the formula for the derivative of surface area. And that came to be, and then again, it's by deriving the left-hand side of the formula and the right-hand side of the formula with respect to t. So I have ds over dt is equal to 8 pi r times dr over dt. Then in the next step, we calculated dr over dt just now, which is the derivative of volume. or it came from us deriving the formula for the derivative of volume. So then I substituted that dr over dt, which was equal to -1 over pi r squared, into the formula that I just derived for the derivative of surface area. So I then have ds over dt equal to 8 pi times 24 times -1 over pi 24 squared. The 24 squared is because they asked how fast is the surface area shrinking when the radius is 24 centimeters. So the 24 centimeters for radius is what I substituted in there to the dr over dt. So then I have ds over dt is equal to 8 times -1 over 24, which is equal to minus a third centimeters cubed per minute, which is how fast the surface area is shrinking when the radius is 24 centimeters.
I agree that I agree with the explanation, and then even the figure or the value that you found at the end. I don't know whether, please ask them whether they did follow your explanation, Darad.
Family members, did you understand my explanation, or is there something that you're confused about? Hello? Okay.
Hi. Evening. Good
Yes.
Good
evening.
evening.
Good evening, Tebogo.
How is everybody? I trust everybody's well. I came late in the meeting. Please forgive me, guys.
No
You're
problem.
welcome, Deborah. You're welcome. We haven't moved far.
I hope I can catch up.
So,
Yeah,
sir
you
was
will.
just,
Yes,
you had a
yes.
question?
Yes, I had a little bit of a challenge evaluating this in our first assignment. So I heard you explaining it, and you used should I call it is it not partial derivatives, but then because
Oh, it's implicit differentiation.
I beg your pardon?
I think it's called implicit differentiation,
It's
where you
implicit.
derive, yeah, because it's not everything is in, like, you have different variables.
Oh, yes.
Like,
Okay.
you know how you'll usually have like y is equal to only x on the one side, but in this
Yes.
case you can have other ones, yeah.
Okay. My question, right? I'm just gonna look at the formula. Now, okay. I would like to know something. You know, like in physics, I don't know if you are doing physics or not, or should we just like
No, you can. I'm not doing physics currently, but I did take it in high school.
okay,
Complicated analogy or parallel you're trying to make.
okay, so like in physics, they would say the derivative of position is velocity, and then the derivative of velocity. So change in position, the derivative of that would be velocity, and then if you take the derivative of velocity, it would be acceleration. So in this case, I look at I had a little bit of a challenge with this. I look at evaluating this, and then I said in my formula, the only thing that changes besides before the surface area, it is r if I actually have an explicit look at the formula. So I didn't when you're saying implicit, so it's also going to be the surface area and the radius on the right. It's not just the radius that's changing. As I don't know if you follow, if you following my question.
Well, the surface area is the one that's shrinking, right? And in
Yes.
terms of the derivative, we're calculating, so we're deriving the formula for the derivative of the surface area, right? So basically a formula for the change in the surface area. And we're doing that with respect to time.
With respect to time.
Yes, because it's dr over dt. Because we're having, it's about the centimeters squared that's changing per second.
Okay.
Because it's how fast is it? Yeah.
Can I ask you a question now? I take my 4 centimeters per minute, right? And then I calculate my volume at my first instance, which would be T1. And then at 1 minute later, it has reduced by 4 centimeters, and then I calculate that volume. And then I have change in R, which is the change in radius. I don't know if you follow me. So then I take that change in R, and then I use it in my formula for my surface area. It's not going to give me a correct what you call this, correct value, because it did not give me a correct value. But then reasoning wise.
Well, I also struggled with these questions in the beginning because I couldn't see how we're supposed to be, because for a lot of these questions with rates in the form of word questions, it's that you use the form, like somewhere you need to be making a formula for the derivative based on the formula that you have to either create from the information or it's directly given to you in the word problem. So with these questions, usually it's a situation of finding the original formula, and then the answer that you're looking for is usually the value. It's usually the answer. Yo, wait, let me try and explain this properly. So usually with these word problems, we had a lot of them where it was basically that you need to calculate you need to find the formula for the derivative based on the original function, which you make up from like the word problem itself. And then before I was trying to do kind of like what you were doing now, where we use like what we would like what we'd commonly think about. So if the question was talking about speed or something like that, we'd use maybe like, I'm not sure, but the main thing that helped these questions click for me was realizing that we have to be working with a derivatives formula. So if we think about this question, it's now we have a balloon, right? And the balloon's spherical. So we have then the formula for its volume and we have the formula for its surface area. The question that we need to get the answer for is asking about how quickly surface area is changing. So the changing and how fast and all that stuff hints towards derivatives. So that's why I keep saying like we need to find the formula for the derivative. And then the other part that was tripping me up was the fact that we then needed to obviously find that derivative formula, but by implicitly differentiating the original formula, which in this case is the surface area formula and the volume formula. So with that one, it's just about remembering in this case, it was dv over dt on the one side for the volume's derivative formula, but on the other side, we were deriving r with respects to t. So that's why then it was dr dt on the other side. I'm not sure if that's making sense. And I only really started to fully understand it after Sir worked through like a couple of these examples. Because even with this question, we had a similar one where a balloon was also losing air, but it was again about then deriving the volume formula or differentiating the volume formula, differentiating the surface area formula, and then those two formulas on their own have missing values, but we use them together to solve simultaneously, and then that's how we get our answer.
Okay. I don't. So, okay, my little question: which one is a derivative of what? Is volume a derivative of surface area, or is it the other way around? If I were to derive.
So basically, you derive. So you have the volume formula, and you find its derivative formula. And then you have the surface area formula, and you find the derivative for surface area's formula.
Okay.
So basically for this question, it was the volume formula they gave to us in the question that V equals 4 over 3 pi r cubed. And then its derivative formula is dv over dt equal to 4 pi r squared dr over dt, which is basically just if we're deriving the form, if we're finding the derivative for this equation with respect to t, neither of these, not like we don't have t in the actual equation, right? So that's why I
Yes.
mentioned implicit differentiation, which is that one where if it's not the subject, if it's not the significant variable, then you add the d over t, right? Or whatever the variables are for whatever situation. So in this case, if we look at the left-hand side, we're differentiating with respect to t. The variable we're working with at the moment on the left is only v. So the derivative of v is just 1, if we think of it just being x, right? So it will just be 1, but it's
Your
not.
reception, I don't know if it's mine or yours, but there's a little bit of a gap in our communication.
Oh,
Your
sorry.
message.
Can you hear me? Can you hear me now? Or am I still breaking?
Yes, it's breaking. It's breaking. I don't know if anybody else is catching that.
From my side, she's okay.
No,
I'm not
then I think
experiencing
it
the
might.
breakage.
No, it's me. Okay, but okay, I'll just look into it again. So I will take the derivative of the volume,
Yes, but do you understand
right?
why?
To get the change in the radius with respect to time, because I have a change in volume. I do not have a change in surface area. So I would need the derivative of the volume to get a change in volume
Yes,
for
the
that
change in
instance.
volume. Because that 4
Yes,
centimeters cubed, the cube tells us that it's the change in volume, right?
yes, not yes, exactly.
Because it's also
So
saying
then
it's escaping the balloon, which is filled with volume of air, and then the volume's getting less as it's escaping, right?
precisely, yes.
Yes, yes. So you can continue?
No, no. So yes, once I have that, then I will use the rate that I got from this derivative of the volume, and then substitute it into the derivative of into the surface area.
Mm-hmm.
Okay.
Because when you
It makes sense.
derive, yeah, because when you get the derivative formula for surface area, so in other words, the change in surface area's formula, because
Yeah.
both volume and surface area have R, right, in their formulae. So that's how they get related, which is why we end up with a drdt in the volume formula and a drdt in the surface area's formula. But obviously they're derivative formulas. Is it making sense, or are some still confused?
Members, are you clear?
I didn't attend the class that where you guys did this, so I'm so confused. I'm not even able to ask to begin with. So I'm hoping to follow as the class goes on. So that's why I was quiet. Yeah.
Let me quickly bring you up to speed. Okay.
Okay.
Yes.
Yes. Prepared.
Here,
Yeah. Let's do this.
here we have got a gas that is escaping a spherical balloon at a rate of 4 cubic centimeter per minute. Okay. Gas is escaping is okay. Before I come in, thank you, Lerato. I will request you to come in again. Okay. Mr. Mandla, we have got this gas that is escaping a spherical balloon at a rate of 4 cubic centimeter per minute. So that means this is our rate of change in volume per time. Do we agree?
Yeah.
At the rate of 4 cubic centimeter per minute, volume is changing as time moves on. Okay?
Mm-hmm.
Full stop. How fast is the surface area shrinking when the radius is 24 centimeters?
Okay.
Here they say, for a sphere, volume is equals to 4/3 pi r cubed. S is equals to 4 pi r squared, where V is the volume, S is the surface area, R is the radius of the balloon.
Okay.
Then, what is it that they need? They say, how fast is the surface area shrinking when the radius is 24 centimeters? Okay, from the first line, gas is escaping a spherical balloon. I'm just reiterating what Lerato has already said. Gas is escaping a spherical balloon at a rate of 4 cubic centimeter per minute. Oh, this is the rate of change in volume. dV over dt is equals to minus 4 cubic centimeter per minute. Are we clear on that one?
Yeah.
Then, how fast is the surface area shrinking when the radius is 24 centimeters? Now, what are they looking for here? The rate at which the surface area is shrinking. They are looking for, remember, they said to us, the surface area is given by this capital S.
Mm-hmm.
In the last line, here, S. Do you see my cursor?
Yeah, I can see the S.
You see this cursor?
Yes.
Yes. S is the surface area. So what is it that they're looking for? They're looking for ds over dt. Okay?
Okay.
Then, in the very same line, they give us the radius. They tell us that the radius is 24 centimeters. Then they stop. Then they come and give us very valuable information. They say to us, for a sphere, volume is equals to 4/3 pi r cubed. And then for the surface area, S is equals to 4 pi r squared, where V is volume, S surface area, or radius of the balloon. Now, we know the rate at which the volume is changing per time is minus 4 cubic centimeter per minute. Here, this, okay?
Mm-hmm.
That's our dV over dt. Is minus because gas is escaping the balloon. Okay?
Okay.
R is 24. V, which is volume, is 4/3 pi r cubed. Now, when we differentiate this volume with respect to T, we end up having 4/3 pi 3r squared dr over dt. Are we clear?
So you said you've got 4/3 pi, sorry, and then you got cut a bit.
Okay, V. Here is V. Do you see this equation for V that they gave us?
Yes,
V is equals to
I can see it.
4/3 pi r squared. Okay.
Okay.
Now we differentiate this V with respect to time. Okay.
Mm-hmm.
Then it will be, on the left-hand side, it will be dV over dt. Okay.
Okay.
Equals to 4/3 pi. Still with me?
Yeah, I'm still with you.
Multiply by 3r squared dr over dt. Differentiating with respect to r. Pi is a constant, eh?
Okay.
4/3 is a constant, pi is a constant as well. So now we differentiate with respect to r. The derivative of r cubed is 3r squared. Do we agree?
Yeah, we agree.
Then multiply by dr over dt. Are we together?
Yes, we are.
Then we do know that dV over dt
Is -4 centimeters per minute, yeah.
Thank you. Is equals to 4. Let me see. Now we've got 4 over 3 pi
pi
3.
squared.
Now, what is our R?
R is 24 as well.
Then in the place of R, we put 24. Then we square it. Okay?
Okay.
Then, after doing that, now we simplify this. We take all these constants to the left-hand side, on the right-hand side, or whether, or the way, or is the way I wrote it. Let me just say, you then make dr over dt the subject of the formula. Okay?
Yeah.
Then you'll be left with -1 over 24 squared pi. We clear?
Okay.
dr over dt will be equals to -1 over 24 squared multiplied by pi. That is dr over dt. Now, what are they looking for? They are saying how fast is the surface area shrinking. So now they are looking for the rate at which the surface area, the rate, time is involved. Once they start to say rate, then time is involved. How fast is the surface area shrinking? When the radius is 24 centimeters. So now, we have to, you see this formula for S which is equals to 4 pi r squared.
Yeah.
This one. Now we have to differentiate this formula with respect to time. So now we will have ds over dt equals to 4 pi 2r times dr over dt. Do we agree?
Yeah.
Then we will have 4 multiplied by that 2, it will give us 8 pi multiplied by r. We know that r is 24. We already calculated dr over dt. Okay?
Yeah, which is that -1 over 24 squared, I think, yeah.
Over pi. Then,
Yep.
when we simplify, we end up having -1 over 3 centimeters squared per minute. So the surface area is decreasing at a rate of 1 over 3 centimeters squared per minute. Does this help?
Yeah, no, it does. It does.
Are you sure?
Yeah, it does. It does. It does.
Okay. If it does, please then let's proceed. We'll skip the next question. Then we'll go to this question number 14. 14 is what we will look at. 14 says, the reason I'm skipping 13 is because we have already dealt with many that are almost similar to number 13. Question 14 says, a block of ice, in the shape of a right circular cone. A block of ice in the shape of a right circular cone is melting in such a way that both its height and its radius r are decreasing at a rate of 1 centimeter per hour. How fast is the volume decreasing when r is equals to h, which is equals to 10 centimeters? I repeat, we have got a block of ice here in the shape of a right circular cone. This ice is in the form of a what? Of a cone, circular cone. This ice, which is in the form of a right circular cone, is melting in such a way that both its height and its radius are decreasing at a rate of 1 centimeter per hour. Full stop. How fast is the volume decreasing when R, which is radius, equals to H, which is height, and both of them are equals to 10 centimeters? Is this making sense, or should I give a clue, or should I give hints? Let me keep quiet for a minute, look at the question, then after a minute, then if you've got something that you need me to clarify, then I will clarify. Okay? Okay, Tebo?
Yes,
You are first in line.
Okay, in this case, this is the opposite of our previous question, because here we've got the rate of change of the radius and we do not have the rate of change of the volume. So here we've got the instantaneous value, and we want to work probably backwards to the one that's in more than one dimension. I don't know if I'm saying that correctly. Because here the change is in one dimension. Well, it's in two dimensions, but then it's in one dimension. It's along the radius, that line, and then along the height.
What you just said, those two pieces of information are very critical and very important in this case.
Okay.
Yes.
So do we integrate? My direct question is, we're integrating here, because I wouldn't know.
Oh, aye. Yours is don't worry. Yours is straightforward. Yours is your question is straightforward, my brother. In this case, no, don't worry. Last line. Please read the last line for us. The last sentence.
I can treat H and R as one thing, because H and R are both equal. So whatever R is doing in the same amount, H will be doing. So, oh, sorry, wait, let me read. You said I must read. How fast is the volume decreasing when R is equals to H, which is equals to 10 centimeters?
Okay. Now, this will help me to answer your question. And probably, having read this slide, you may be in a position to answer the very same question that you asked me. Therefore, how fast is the volume decreasing when R equals to H, which is equals to 10 centimeters? What are these people looking for?
Wait, they're looking for the change in volume.
The change in volume, yes. How do we get the change in volume? We get the change in volume by differentiating volume with respect to time.
Again.
Yes.
Oh, yes, I see it. I'm so sorry. I see it, yes.
So okay. That hint was very helpful.
I'm sorry.
Was it?
to look at the last sentence in the question, because I was getting hung up on, now what does it mean? How am I supposed to work with this 1 centimeter per hour? And then, because I was worried about that, and I was thinking, oh, how am I going to find the formula for the derivative of the radius and what? And then I just looked, then when you said that, I looked at the question, and then, so it makes sense now.
Okay.
What was the doing?
I'm happy that it is beginning to make sense. Now, please, let's go to the first line. Is everything in the first line making sense? Is it understandable to everybody?
Yes.
Oh, okay. Thank you. How many minutes then do you need to work this exercise?
I think 3.
Now, let me go over this question again. The most important thing that you can do to help yourself in solving these type of questions is to break. Don't read a question from the first line up to the end and try to understand it at once. Okay, that is just my view. We differ in terms of the level of understanding. But what I usually do, I read a line and ask myself, which information are these people sharing with me here? Then I captured it. After that, I go to the next line to try to understand the message or the information that is shared with me to can be able to answer the question. All right, before I come in with what I got, Kamorelo, Lerato, please talk between yourselves. Oh no, we are many. Please talk amongst yourselves and also bring in those others who are quiet so that I can hear what you got before I come in.
Okay, so my answer is I've got 100 pi centimeter cube per hour.
I got negative 100 pi centimeters
Yeah,
cubed per hour.
decreasing, yes, it's negative.
I have the same answer.
Oh, okay. I also agree with the constant or the number that Camarello and Dorato have shared with us. The volume is decreasing at the rate of 100 pi centimeter per hour. We agree,
The
ne?
Adivala also got that answer.
Okay, thank you.
Sir, may I ask you a question? Yeah, I'm going to leave at 5 past now. I also got that answer, but then for some reason, because I derived at 1/3 pi, and then it was r cubed, and then I had pi r squared. Delta, yeah, and then it's so my derivative of the volume with respect to time is equals to pi r squared dr over dt, and then I substituted it into there. Was that the correct approach? And then, but then once
Deborah, slowly, my brother. I need to clearly. Oh, okay. I don't know whether I should go first or whether to wait for you to go first or not. But okay, let me request you to go first, and then please, members, let's listen attentively because from what Deborah has just shared, I picked it up that there was something that was just missing. But I just don't want to say there is something missing from what Deborah said until we clearly give him an opportunity to explain to us what he just said so that we can be able to, if there is a need for us to help him, then we can be able to help him. If we agree with his answer and then with everything that he would have said, then we'll just proceed. Deborah, please proceed, my brother.
Okay, I had the formula for volume 1/3 pi r squared h, and then I said h and r are equal, so I said let h be r, and then I had 1/3 pi r cubed. So that was the formula for the volume, and then I derived it. And then I had dv over dt is equals to pi r squared dr over dt. And then I substituted my value, and then I got dv over dt is equals to is equals to pi 10 squared dr over dt. And then because I was looking for dr, I then said dr, so then that's where I came to 100 pi, right? And then I said, because I'm looking for dr, with respect, I was looking for the change so I said, I took it that side, and I said dv dt times 1/pi 100 pi is equal to dr over dt. And then I went to the formula for area, and then I derived it, and then I had, but I ended up with 1/pi 100. Let me just put it at that, because I was still trying to do the magic on the other formula, but obviously.
Why were you working with area?
I can't explain myself there, but
because I'm just wondering, because I know in the other when I was explaining the other question,
Yes.
I was talking about the surface area, but that question brought up surface area, and it's not like just that question applies to all questions like of these types. But yes, I agree with you, and I didn't even think myself to say, they say that R and H are the same, so why not just make the H equal to R? That would have simplified my calculations a lot.
Yeah, but then why do I come to 1/100 pi as opposed to?
Well, I don't know where you got you said
1/100 pi, yes.
When you after you calculated the derivative, your 1/3 and your 3 cancel out, right? And then you sub in the 10, and then you get 100, and then you sub in your dr dt, which is -1, and then you get -100/pi. Because I was writing out the question as you were explaining it, and I still got the same answer. I don't know where you got to have pi in the denominator.
I didn't take the dr as -1. I didn't. I said dr is what I'm looking for. So I isolated dr and then took everything else, the dt over dt, they canceled out. And then I just had dr is equals to 1/100 pi dv.
Oh, well, in this case, because the dv dt was what we were looking for, which is basically how fast volume's decreasing, the change in volume. So you didn't have to like take it over.
I'm following.
But otherwise, I like your method more. I have so many numbers now here, substituting 10 in 3 different times just to get to the same answer.
Okay.
Because when I ended up deriving it, I had to say the derivative, I had to use the product rule, and that one breaks it up. So the derivative of the first times the second plus the derivative of the second times the first, and then I ended up with like 3 instances where R and H occur. But next time I'll be smarter like you, and I'll take the easy hint that the question's throwing at us by saying R is equal to H.
Also, thanks. I'm appreciating the help, guys. I gotta go home.
You are welcome. That is
Okay,
what we are here for.
Good night, fam.
Sure. All right. This is how I approached it. I said volume. is given by, the equation for the volume is given by pi over 3 r squared h. And then, what do we know? What do I know from here? I know that the height for this ice, dH over dt, I said, is minus 1 centimeter per hour, because it's decreasing. And then the radius is also minus 1 centimeter per hour. That is what, this is the information that I've been able to source or to obtain from this question. Then differentiated this equation for volume with respect to t, then I ended up having dv over dt is equals to pi over 3 r squared dh over dt plus pi over 3 times h times 2r dr over dt, which equals to pi over 3. We know that radius is 10 centimeters. 10 squared is 100, multiplied by dh over dt, which is minus 1, plus pi over 3. H is 10. 2 times r. 2 times 10. Multiplied by dr over dt, which is minus 1. That's how then I ended up having minus 100 pi, from which I concluded to say the volume is decreasing at the rate of 100 pi centimeter per hour. Okay. May we please proceed?
Yes,
In the
sir.
absence of,
Yes,
in the
sir.
absence of a question from this. I'm also getting worried about you. Now, here, let me see. Yeah, this is all. Yes. In a right triangle, leg X, in a right triangle, leg X is increasing at a rate of 2 meters per second, while leg Y is decreasing, so that the area of the triangle is always equals to 6 meters squared. How fast is the hypotenuse Z changing when X is equals to 3? Please allow me to repeat. In a right triangle, leg X is increasing at the rate of 2 meters per second, while leg Y is decreasing, so that the area of the triangle is always equals to 6 meters squared, or 6 square meter. Then, how fast is the hypotenuse Z changing when X equals to 3? Have you got an idea, or should I share a few hints?
Still thinking about it, sir.
Oh, okay.
Mm-hmm.
Okay, let me keep quiet. I'll wait for you if you need my assistance. All right. Please, let's talk.
So I don't
Yeah.
know, because so I knew when they were mentioning right angle triangles, we might need to use the derivative of the Pythagoras theorem.
Yes.
So then, is it fine that I'm explaining what I did?
I don't know whether. Please talk to Kamarel whether he's comfortable with that.
You can explain, it's fine.
Okay, because I'm still confused. Like half of the question is filled out, and then the other half of it is still there's gaps. So yes, so they give us that when they're referring to the legs as x and y. I'm assuming the leg for x is the base of the triangle, and the y is the height of the triangle. And then at the base, I made x equal to 3, and then that dx over dt is equal to positive 2. And then my y, I made it equal to 4. And then they gave us that the y is decreasing at a rate that the area is equal to 6 meters squared. That's the one that I couldn't, I thought I assumed I would need to relate the area to the derivative I figured I would need to relate the area to dy over dt to get a value for dy over dt, but I couldn't figure out how to relate those two. Because then what I have on the other side, when I'm busy calculating, is x squared plus y squared equal to z squared, and then the derivative of that equation. But I've managed to find the values for everything else except for dy over dt, because what we're solving for is dz over dt.
I agree.
So I couldn't, I'm stuck at how I find the value for dy over dt. I wanted to say, is it not equal to 0? But that can't, like, I don't think that's right, because they're telling us it's decreasing at a rate. The rate is a decreasing rate, so it can't be that it's 0. There has to be a value for it. And I couldn't figure it out. But I am assuming we're going to calculate it, or we get that value by linking the area formula, to dy over dt.
Okay. I agree with what you are saying. Now, the whole idea or the whole idea is to remember the formula for the area of a triangle. What is
Yes,
the area? What is the area? What is the formula for the area of a triangle?
A half
It's
base times
half
height.
base times height.
Half base times height. In this case, we know the area is 6. Do we agree?
Yes, sir.
Yes.
6 is equals to half times xy. Do we agree?
Yes,
Yes,
that's why
sir.
it's 12. Yes.
Yes. Area is 6 is equals to half times x, which is 3. Which they
Yes,
gave
sir.
us that. They gave us that x is 3. Okay. Then
Yes,
from
sir.
there, we get y. Do we agree?
Yes, sir. It's equal to 4. Yes, sir.
Y equals to 4. Clear, ne?
Mm-hmm.
Now, from there, okay, from here, from this y equals to 4, do we agree that we can be able to get what z is?
Yes, sir.
Using the theorem of Pythagoras, as you said, Larat.
Yes, sir.
Yes, sir.
We got z to be 5.
5.
Now we know x is 3, y is 4, z is 5. Clear, ne?
Yes, sir.
Okay. Now, let's go back to that formula for the area of a triangle. We say the area A is equals to half XY. Okay? Then
Yes, sir.
A is 6. In the place of A, we put 6 equals to half XY. Okay?
Mm-hmm.
Then we say XY is equals to 12. Are we clear?
Yes, sir.
Yes, sir.
Then we have got two variables here, XY equals to 12. We have to differentiate XY equals to 12 with respect to Y. We have to differentiate XY equals to 12 with respect to Y, as well as with respect to X. Clear?
So,
So, XY equals to 12. The derivative of
And then the derivative of 12 is 0.
Sorry?
You can continue, sir.
Yes, the derivative of 12 is 0. I agree with you because it's a constant. So now we have got XY equals to 12. Now, when we differentiate with respect to the first one, which is X, we'll just have dx over dt times Y plus. Now we are going to differentiate with respect to Y. Then we'll just have X. We'll have plus X dy over dt equals to the derivative of 12, which is 0. So it will be Y dx over dt plus X dy over dt equals to 0. Right. Now we know, we were told that from this question, we are aware that dx over dt equals to 2. Do we agree?
yes, sir.
Plus x is 3 multiplied by dy over dt. What is y?
Y is equal to 4.
Yes. So now we have got y dx over dt plus x dy over dt. So in the place of y, then it will be 4 times dx over dt. It is 4 times 2 plus x dy over dt. X is 3. Is 3 times dy over dt equals to 0. Therefore, dy over dt is equals to negative 8 over 3.
Yes, sir. Okay, so I see now. Because I figured we'd have to go back to one of the formulas, but I don't know why I was trying to go back to the main formula we were going to get our answer from to try and get a value for dy over dt. So we used the area, and then we didn't sub in the values for x until after we found the derivative of that equation.
Rato, what are you saying? I don't
So
want to.
basically,
I'm not denying. I'm not agreeing until I
yes.
clearly understand what you are saying.
Okay, let me say it proper because I see it's 3 minutes after 12:30. So
Okay.
I was saying, as I said in the beginning when I was confused, that I knew I had to relate the area and the derivative, or I had to relate area and dy over dt somehow to get the value for dy over dt. I just didn't realize that I should have taken the formula for area and simplified it to only have, so how you simplified it, you took the half over to the other side after subbing in 6. And then we worked with that xy equals to 12. And then we found the derivative of that to help us get the answer. I was thinking, oh, maybe I must just try subbing in x as well. Like already at that beginning stage of xy equal to 6, I would have thought to sub in the value for x, but I see now why we didn't and how that helped us to get our answer.
Then from here, then after getting dy over dt, We then go back to theorem of Pythagoras. We differentiate. So we
Yes,
will
sir.
have 2x dx over dt plus 2y dy over dt equals to 2z dz over dt. We know what x is. We'll multiply x, which is 3, by 2. Whoa. Slowly. Whether we can divide this whole equation by 2. Whether we do that, oh, yeah, we can divide the whole equation by 2. Then we end up having x dx, x is 3, dx over dt is 2, plus y is 4, multiplied by dy over dt, we just found it to be minus 8 over 3, which is equals to z, which we found to be 5, times dz over dt. dz over dt is what we're looking for. We just simplify, then we end up having dz over dt being equals to minus 14 over 15. So the side is decreasing at a rate of 14 over 15 meters per second.
So what's the
Come on.
final answer again?
Minus 14 over 15 meters per second.
Okay, sir.
Mm.
Thank you.
Okay, you're welcome. Is it making sense?
Yes.
Okay.
Yes, sir.
Now, please, let's. That means I'll still have to. Meaning I must relax until you master this, because it's of no use for me to rush through this section if you are not mastering this. Now let's look at number 16. Number 16 is talking about a girl. Says, this girl is flying a kite. This kite is attached to a string, or is on a string. A girl is flying a kite on a string. The kite is 120 feet above the ground. And this wind is blowing the kite horizontally away from the girl at 6 feet per second. At what rate must this girl let out the string when 130 feet of string has been let out? A girl is flying a kite on a string. The kite is 120 feet above the ground. And the wind is blowing the kite horizontally away from her at 6 feet a second. At what rate must she let out the string when 130 feet of string has been let out? Okay. How many seconds or minutes do you need to figure it out and work it out?
We don't know.
You don't know. Okay. Should I give you a clue?
Yes,
or do you need to? Okay, let me keep quiet. Take a minute to visualize the situation. Then I'll start to talk. Okay.
okay.
Please, now let's talk about this. Let's look at the first line. First sentence is saying, a girl is flying a kite on a string. Okay? Now, meaning this girl is holding a string, and then this string is attached to the kite that is in the sky. Okay?
Yes, sir.
Then, next line, it says, the kite is 120 feet above the ground. What do we know? That is the height, or
Yes,
y.
yes.
That is the height, or y. Then it says, and the wind is blowing the kite horizontally away from her at 6 feet per second. This kite is blown away from the girl by the wind horizontally away from her at 6 feet per second. What is this? The wind is blowing the kite horizontally away from the girl at 6 feet per second.
Is that dx over dt or something like that, because it's horizontal?
The change in height in respect of time.
We agree. I agree with that.
Yes.
Dx over dt is 6 feet per second. Now we go, okay, we captured important information from the first line. The second line, yes, we captured what we think is important. Then now we are going to the last line. The last line is saying, at what rate must she let out the string when 130 feet of the string has been let out? Okay, please, let's talk here. We know why, we know the height is y, which is 120 feet.
Yes, sir.
We know that dx over dt is 6 feet per second.
Yes.
What is this 100? At what rate must she let out the string when 130 feet of the string has been let out? What is this 130 feet?
Z, which is the hypotenuse.
The hypotenuse.
That's the hypotenuse. I agree with you. Then, are we clear up to so far?
Yes, sir.
Now, if we agree, knowing that we know what y is, and we also know what z is, do we agree that we can be able to find x?
Yes, sir.
Yes, right.
Yes. Then the next thing, okay. The next thing will be to find x, and after that, okay, this is the clue that I need to give. Okay, we know the x over dt is 6 feet per second. Then this information that we are having, you will be able to find dy over dt. Do we agree? Yes, no?
Sir?
You will be able to find dy over dt. Do we agree?
Yes, sir.
Okay, thank you. Then the next thing, I need to make, oh yeah, before I say what I need to say, please let's go back to the last line. It says, at what rate must she let out the string when 130 feet of the string has been let out? Okay, from this last line, I agree with the information that we got from this last line. Remember what we said about the information that we got from this last line? Yes? No? From the last line, last sentence.
That the hypotenuse is 130 feet.
Yes, we agree, né?
Yes, sir.
From this last line, again, there is another important information that we need. What is it? Mr. Mandla?
Yes, sir. So I think, yes.
I agree
Mhm.
that Z
Yes.
is 130. I'm in
Yes.
agreement. But from
Okay.
this line, there is another important piece of information that we somehow didn't get, which we need to
Yes.
get. Mhm.
Yes, sir.
What is that?
I think that's the imaginary X to complete a right angle triangle of some sort.
That one we agreed. Remember, we
Okay.
agreed about Y. Eh? We also
Yes.
agreed about the Y. We also agreed about the Z.
Mhm.
So now the two values will be used to calculate what? X. Okay?
X. Yes.
Yes. Now on that one, I'm stopping here. Then I'm now coming back. I'm saying, from this last line, there is another piece of information which is important that we didn't pick up. Which information is that?
Is it information we need to find, or is it there already?
Aha. Aha. What you just said. What is it that we need to find here?
dz over dt, because she's letting go of the string and the kite is at a hypotenuse to her because it's already been blown. So I think the question is asking for dz over dt.
Thank you, my,
yes.
brother. So now, y, z, we know. Then we can be able to find the x. Then from there, we can be able to use theorem of Pythagoras to find what you just said, Mr. Mandla. Okay?
Yes, sir. Yes.
Am I helping? Have I helped?
So far, yes.
Okay. So now from here, will it be ideal for me to say you can now be able to work this thing out?
Yes, sir, yes.
Okay, please let me then keep quiet. But before I keep quiet, ask you how many minutes then do you need to work it out? You use all the information, all this information that we just spoken about.
I think 5 is okay. I got the answer.
You got the answer?
Yes, sir.
Okay.
I'm not sure
Now,
if it's correct.
no, don't have to worry about that one. Let's ask Mr. Mandla. Mr. Mandla, are you winning or
As I said, the winning is very slow.
is very slow?
Yes, yes, yes. Maybe I can assist my colleague as he goes through his to see if we got the same thing.
Okay. All right. Can I then, or will it be an incorrect? Will I be incorrect? Or to say somehow you have got an answer which you just don't believe in, or what?
Is that question directed to me?
Yes,
Yes, no, I don't believe in the answer. Yeah, it
but
doesn't.
you have got it, eh? All right, all right. Don't worry. Let me start with you. We are in this together. Don't worry. Don't panic. Please share the answer that you just calculated. The one that you just found.
Is that me or?
Yes, yes. Then I will then go to Kamal.
Oh, okay. So first, right, we said we're calculating x, right? So
Yes.
yes, I calculated my x to be 50, first of all.
X. Okay. You got X
Yeah,
to be 50.
yes.
I agree with that.
Okay. After I got my
no.
yes, sorry.
Let me not agree or disagree. Let me just listen. Okay. At this point in time, I'm not going to comment. I'll just be listening. Okay. Yes.
Yeah, okay. No, that works as well. That works
All
as well.
right.
Yeah, so I got my X to be 50, right? Sorry about that.
Okay.
Yeah, it's my alarm to say that I should stop studying. So X was 50, and then from there I tried to calculate the area of the imaginary triangle. So that would be half x by y, which would be 1/2 by 50 by 120. And then 50 by 120 is 6,000. So the area itself is 3,000. And then from there, I tried to find dy over dt following the approach we did in the previous problem. So that became -6 by 120 divided by 50. That's why I started not believing. The numbers were too big, and I just I didn't pass that level.
Okay. Thank you, my brother. We are in this together. Don't worry. Kamalo,
Yes, sir.
how did you approach it, my brother?
Okay, so what I did is I used Pythagoras to find. Wait. I used Pythagoras, right? I differentiated just using the formula before finding x.
Or you differentiated theorem
The
the formula
yes,
for the theorem of Pythagoras. Okay.
yes. Then I've got that s and change of s respective to time is equals to x times change in x in respect to time. Then I went ahead and find x, which is 50, and I found what do you call the hypotenuse Renalo one already, so it's 130. So I substituted everything that I already have. Then my
Mhm.
final answer was 30 over 13.
All right. I agree with the final answer. Now we need to help Mr. Mandla. Samuel, please let me request you to start the explanation slowly so that we can try to bring Mandla up to speed. Mr. Mandla, if there is any step where you get lost, please interrupt, okay?
Yes, noted,
Then,
Dr. Glenn. Yeah.
then we'll help. Yes. Okay.
Okay, so firstly you said you found X as 50 feet, right?
Yeah.
So that's fine as your first step, ne?
Okay.
So what you want to do next is use the Pythagoras theorem.
Yeah.
Yeah, you differentiate the Pythagoras theorem, ne?
Yeah.
Yeah, that way it'll make it easier. So by differentiating, so in the statement they said only it changes only horizontal, which is only X that is changing.
Okay.
And Y is not changing, so that's 0.
All right. Yeah, no, I follow you. I've
Yeah.
got it now.
Yes, that's why I said the horse chabile.
Yeah, you can speak in Venda if
Tshwara
Nah.
sekgose.
After 8. But it's fine. So that's why I said the derivative of the Pythagoras theorem is 2s. I mean it's more or less the same. 2s times the change in hypotenuse in respective of time is equals to 2 times the base, which is x, the change times the change of it in respect to time. Then I substituted everything. You already have the hypotenuse and you already have the, what do you call, x and the change of x. Then it's going to be 130 times ds over dt is equals to 50 times 6, which is 130 over 130 times ds over dt is equals to 300. Then 300 divided by 130 is equals to 30 over 13.
Thank you, Kamalu. Mr. Mandla.
Yes, sir.
Okay. I'm just adding to what Kamal has already said.
Yes, sir.
We agree.
Yeah.
From the theorem of Pythagoras. From the theorem of Pythagoras, we agree that x is equals to 50. Then we take that theorem of Pythagoras, which is x squared plus y squared equals to z squared.
Right.
Then we differentiate it with respect to t. So it will be 2x times dx over dt plus 2y times dy over dt, which is equals to 2z times dz over dt. Are we still together?
Yes, Dr. No, I missed that it doesn't blow up. It blows
Then we divide this equation, the entire equation, by 2. We end up having x dx plus y dy. We have got x dx over dt plus y dy over dt, which is equals to z dz over dt. Clear? Then we know that x is 50 and dx over dt, we agreed that is 6. And then we know that y is that 120. The derivative of 120 is 0. So dy over dt is 0. So now this makes this y, which is 120 times dy over dt, makes this term to be 0, which then equals to 130 times dz over dt. Making dz over dt the subject of the formula, then we end up having that 30 over 30. Is it clear?
Yeah, it's very clear. It's very clear.
Thank you. Thank
Sir,
you.
before you proceed, is there any method that we can use excluding this one?
Hey, who's talking?
Adele.
Adivao, you have been
Yes, sir.
hiding. Is there any method
Yeah, that we can use excluding this one.
excluding this one?
Yes.
Hey, if there is another one, then that means I still have to go and do my research. This is the one that I'm aware of.
Oh,
Okay,
yes.
thank you. Now, let's look at Adivao.
Yes, sir.
Thank you. Please read out question number 17 out for us.
Okay. A thin circular metal disc changes size but not shape when heated. The disc is being heated so that its radius is increasing at a rate of 0.03 milliliter per second. How fast is the area of the disc changing when the radius is 200 millimeters?
Thank you. Okay. How should I start? Okay, this is how I should start. From the first sentence, they are saying a thin circular metal disc changes size, but not shape when heated. Okay? Clear? I just repeated what Adeva read out for us. Next line says, the disc is being heated so that its rate is increasing at a rate of 0.03 millimeter per second. How fast is the area of the disc changing when the radius is 200 millimeter? Okay, before you start to work it out, okay, let me keep quiet for 30 seconds. Please apply your mind to it. And then after 30 seconds, I'll start to talk to you so that you can share with me how you think you will approach this. All right. Anyone? How do you think this exercise will be approached?
Are we not finding the rate of change of area?
Are we not?
Finding the rate of change of the area. Anchor, we are given the rate at which the radius of a circular metal disc is increasing, which is 0.03. And we are also given a radius where R is equal to 200 milliliters.
So now, what are we looking for?
The rate of change of the area.
Yes. Please tell them.
Guys, did you hear that?
Yes, 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 yes.
How many minutes do you need?
2 minutes.
2 minutes. Thank you. Numbers, you've got 2 minutes. All right. Is there anyone who has got an answer?
Yes, sir.
Okay, my brother, what did you get?
I got 12 pi.
Please ask them whether they agree with you or disagree with you while I'm reserving my comment.
So family members, do you agree or disagree with the answer I got?
Hey, my brother, finally I got something that someone else got. Eh? Yeah, hey, these maths lit like questions. Hi, shy, blind.
English is bad. Eh?
I'm telling you, man.
I got the
this
same
English
answer
is too
too. Sorry
much.
to this.
Okay, okay.
What is the answer that there is an agreement on?
12 pi
12 pi. That is also what I have here with me.
milliliter squared.
Yes. Meters per second.
Yes.
Yes. So this is measured in millimeters. Yeah, millimeters.
Yes.
Yeah, it's millimeters.
And you have to
Millimeters.
square the milliliter, sir.
You have to square.
Yeah.
And then finally, what will the answer be? 12 pi what?
Milliliter squared per second.
Thank you. I agree with that number. And now, what should I? Let me see something from my side. Okay. Do you see number 18 and 19? I think only these two. Can I request you to take a screenshot of these two? And then just try, during your spare time, just try to work them out. And then tomorrow, we'll start by checking the figures that you would have found. I need you to be comfortable at handling this. Then that, in that way, then I'll be comfortable to can be able to step off this section. And then let me thank you family members for coming and then participating.
Bye.